All right, today we are digging into something that is absolutely fascinating and, incredibly relevant right now: science diplomacy. This is one of those ideas that's shaping our world in ways you probably don't even realize. So let's just jump right in.
So let me start with a question for you. Why on earth would scientists from North Korea, the UK, and the US all decide to collaborate? I mean, these are countries with some, let's just say, strained political relationships. And they're not just collaborating on anything, they're studying an active volcano, Mount Paktu, right on the border of North Korea and China. This thing was responsible for one of the biggest eruptions in recorded history. On the surface, it just sounds impossible, right? How could that even happen?
Well, the answer to that puzzle is a really powerful and increasingly important idea called science diplomacy. Think of it as this special channel that allows for collaboration and communication, even when all the usual diplomatic phone lines are, completely frozen solid.
Okay, so what is science diplomacy really? To get a grip on it, we've got to rewind the clock a bit and look at the original blueprint, the framework that pretty much defined this whole field for over a decade.
So, at its heart, it's pretty simple. Science diplomacy is all about using scientific collaboration, teamwork, across national borders to tackle problems we all share. Huge things like climate change or, hey, a potentially catastrophic volcano. And the hope is you build some constructive partnerships along the way. The modern version of this idea really took shape back in 2010. That's when two huge scientific organizations, the Royal Society in the UK and the AAAS in the US, put out this landmark report. You got to remember, 2010 was a pretty optimistic time, and this report laid out this beautifully simple and hopeful framework for how science and foreign policy could actually help each other out.
And they broke it all down into three key ideas, what they call the three pillars of science diplomacy. This framework, it's been the foundation of this conversation for more than 10 years. So let's quickly unpack each one.
So pillar number one is science in diplomacy. This one's pretty straightforward. It's all about making sure our foreign policy decisions are based on solid, high-quality scientific advice. The perfect example? The IPCC, the Intergovernmental Panel on Climate Change. You got thousands of scientists from all around the globe volunteering their time to tell world leaders, here's the science on climate change. And that advice directly informs huge international agreements. Okay, pillar number two, diplomacy for science. Now, this one kind of flips the script. This is where we use the tools of diplomacy to make massive international science projects happen in the first place. Think about the Large Hadron Collider at CERN. There's no way one country could build or fund that thing on its own. It takes an incredible amount of diplomatic heavy lifting to get all those countries to work together, pool their money, and share the tech. And that brings us to the third pillar, which is maybe the most hopeful one: science for diplomacy. This is the idea of using science itself as a soft power tool, as a way to build bridges and improve relationships, especially between countries that don't get along. The prime example here is the Sesame Project in Jordan. It's basically a particle accelerator that brings together scientists from all over the Middle East. We're talking Israel, Iran, the Palestinian territories, all working shoulder to shoulder on pure science. It's an amazing example of science-building trust where politics just can't. So that three-pillar framework, it's really elegant, right? It's simple, it's optimistic. But, and this is a big but, the world has changed. A lot. That hopeful spirit of 2010 has slammed right into the much messier, much more confrontational reality of today. And don't just take my word for it. The Royal Society, one of the groups that created the framework, said it themselves. They pointed out that since 2010, politics in places like the UK and the US have become way more polarized. And globally, nationalist politics are definitely on the rise. That changes everything. And here's the bottom line. The world of today is just a totally different beast than the world of 2010. That simple, optimistic model of everyone just collaborating for the good of humanity, it's now under some serious pressure in a world that's become way more competitive and, frankly, a lot more distrustful. And you can see these new pressures everywhere. We're not just talking about one thing. It's a whole bunch of stuff. You've got the rise of nationalism and this intense strategic competition. You've got real worries about research security and even espionage. Then there's the flood of misinformation that scientists have to constantly fight against. It's a lot. When you put it side by side, the shift is just stark. The 2010 ideal was all about open collaboration. Now, the reality is strategic competition. Back then, the focus was on soft power,
Today, it's balanced with serious national security concerns. We went from assuming trust to demanding trusted research only with certain partners. And that beautiful idea of science as a universal good, well, now it's often seen as a national asset to be protected and leveraged. It's a whole new game. So if that old optimistic playbook just isn't cutting it anymore, what's the alternative? Well, a lot of experts are proposing a new playbook, a much more flexible and frankly realistic way of looking at things. It's built around 4 different modes of operation, or what they call action regimes. And the key word here is flexibility. The idea is that one-size-fits-all approach just doesn't work in this complicated new world. Instead, we have to recognize that countries are going to act differently depending on the context, the science, and the politics. They switch between these different regimes based on the situation. So let's look at these 4 regimes. First, you've got the ideal regime. This is that classic, hopeful vision we talked about, science as a shared global resource. Then there's the crisis regime. Think about the early days of the COVID-19 pandemic, that frantic, improvised cooperation to deal with a sudden global threat. Third is the like-minded regime. This is where you see selective partnerships, basically science clubs made up of allies who share political values and security goals. And last, you have the sovereign regime. This is science as an instrument of national power, all about competition and gaining a strategic advantage. Now, here's the most important part of this whole new model, so really lean in for this one. Countries don't just pick one of these boxes and stay in it. No, they're constantly moving between all 4 of them, often at the same time. So a country might be fully cooperating in the ideal regime on something like astronomy, while at the exact same moment competing like crazy in the sovereign regime on something like AI. It's a constant strategic balancing act. So where does all this leave us? Well, it brings us to a huge crossroads. And this isn't just about the future of science, it's about the future of how countries deal with each other, period. That core tension is just staring us right in the face. Are we going to cooperate or are we going to compete? We are truly standing at a critical moment in time, and the choices we, as a global community, make in the next few years are going to have massive, massive ripple effects for every single one of us. Because on one side of the coin, you have science as our greatest tool for working together, right? The search for knowledge is universal. It doesn't care about borders. That makes it the perfect way to tackle the giant global problems that affect all of us, whether it's preventing the next pandemic or dealing with climate change. But flip that coin over. That very same power makes science an incredibly tempting, incredibly potent asset in a global race for dominance, for technological supremacy, economic advantage, even military power. It can so easily become just another battlefield, another front in a new kind of global competition. So yeah, the stakes could not be higher. How we navigate this delicate dance between science and politics, it's not just going to define the future of research and discovery, it's going to fundamentally define the kind of world our children and grandchildren will inherit. So, it all comes down to this one vital question we have to ask. In the 21st century, will science be our greatest bridge or our next battlefield? The answer, well, it's still being written. Thanks for joining me for this explainer.